Welcome back, my dear students. So in the last class we have seen about the Bernoulli's equation. Okay, so Bernoulli's equation, what is that and what is its formula? We derived it in the last class. So we'll see some of the practical application of the Bernoulli's equation. Okay, now so Bernoulli's equation is applied in all the problems of incompressible fluid where energy consideration are avoided. Okay, but we shall consider its application to the following measuring devices. So on this Bernoulli's equation, we have three measuring devices which works on the principle of Bernoulli's equation, that is Venturimeter, orifice meter and pitot tube. Okay, so what is this Venturimeter? We will see. Orifice meter, what is that, and what is pitot tube? We will all see these three devices separately, and also we have some problems on the three devices. Okay, so once we get to know about these devices, the problem will be very easy. And what I do is just for this class we will see the theory part. Okay, then one theory part and one problematic part, so two classes we will there for the devices. Okay, so first we will see the Venturimeter. So what is this Venturimeter? So the Venturimeter is a device used for measuring the rate of flow of a fluid through a flowing pipe. Okay, so it consists of three parts. See, this is the picture of this Venturimeter. So it is the device used for measuring the rate of flow of a fluid flowing through a pipe. See, it has three parts. What is having three parts? So see here, the slope is converging. Okay, so it is converging, right? A short part converging, then again it has a throat which is which has no slope. See here, this point has no slope, but it has some slope like this. Okay, and again it is again raised. So this is how the construction of the Venturimeter is. Okay, so Venturimeter, what are the parts of Venturimeter ಅಂತ ಕೇಳಿದ್ರೆ, so it has three parts. ಯಾವ್ದು? So a short converging part, throat ಅಂತ ಹೇಳ್ತಾರೆ ಇದಕ್ಕೆ, throat, it is called as throat. Okay, this is converging part and this is what? Diverging part. Okay, diverging part. So I can't write with the mouse. Okay, see, so this is the image of the Venturimeter which is practically available in the market. So for theoretical view we will take it, we will take the schematic representation of that. Okay, so we will see now. So Venturimeter, so a Venturimeter is a device used for measuring the rate of flow of a fluid flowing through a pipe. Why it is used? It is used for the measuring the rate of flow of a fluid flowing through a pipe. So it consists of three parts. ಯಾವ್ದು? ಒಂದು ಶಾರ್ಟ್ ಕನ್ವರ್ಜಿಂಗ್ ಪಾರ್ಟ್, ಥ್ರೋಟ್ and diverging part. Short converging part ಯಾವುದು? ಈ ತರ ಇತ್ತಲ್ಲ ಅದು ಥ್ರೋಟು. Okay, diverging part it was rising. So it is based on the principle of Bernoulli's equations. Now for this Venturimeter, what we will do, we will assume and we will derive one equation. So ಆ equation ಇಂದ ನಾವೇನ್ ಮಾಡ್ತೀವಿ, Venturimeter ಮೇಲೆ ಬರುವಂತ ಪ್ರಾಬ್ಲಮ್ಸ್ ನ ಸಾಲ್ವ್ ಮಾಡ್ತೀವಿ. Using that equation we will solve the problems coming on this Venturimeter. So we will derive that equation first. So expression for the rate of flow through the Venturimeter. Okay, so whenever we express something, no, what we have to do, we have to consider, we have to assume. So consider a Venturimeter fitted in a horizontal pipe. Okay, so this is the short means the Venturimeter is considering to the pipe, it is very short. Okay, so it is fitted in the pipe. Okay, once you know the diagram you will get to know. So consider a Venturimeter fitted in a horizontal pipe through which a fluid is flowing. So as shown in figure. See, this is the figure. Okay, already water is flowing, so this is connected. So this diagram is there. No, this diagram tells us it is continuous, but we can't show fully pipe. No, that's why it is cutted. If you see this type of indication, it is continuous like that. Okay, so this pipe is continuous and this is the part of the Venturimeter. Okay, So now what we'll consider, let d1 be the diameter at, we will take sections at the Venturimeter, inlet section where it starts, okay, and also this at here is the outlet section, okay. So it has some tubes to measuring the pressure, okay. So let d1 be the diameter at inlet or at section 1. Let d1 be the diameter at inlet or section 1, p1 be the pressure at section 1, and v1 be the velocity of fluid at section 1. So d diameter, p pressure, and v velocity of the fluid at section 1. So what is the area? So area is small a. Area of the section is what? Pi by 4 d1 square. So when once we know the diameter, we can easily find the area of that pipe. That is pi by 4 d1 square. Okay. So this is the diagram, and this is at the section 1. So similarly, we will take at the section 2. What is that? We will take d2 as diameter at the section 2. Okay. Pressure at a section 2 is this. Velocity of fluid at section 2, and area A2 is the area of the section at 2. Okay. Similarly, as we took in section 1, d2, p2, v2 and a2 are what? Diameter, pressure, velocity and area at section 2. So next we will try to solve. So now what we do, we will apply the Bernoulli's equation at section 1 and 2. At both the section we will apply. So what is the formula of Bernoulli's equation? So P1 by rho g plus V1 square by 2g plus Z1, which is equal to at section 2, which is P2 by rho g plus V2 square by 2g plus Z2. So this is the Bernoulli's equation we know. Just we have to add what? At section 1 means 1, 1, 1. And these are constants, these are same because water density is same, g is same, okay. So at section 2, p2 by rho g plus v2 square by 2g plus z2, okay. But here what is the case? The pipe is horizontal, right? The pipe is horizontal, so z1 is equal to what? Z2. So this z1 is equal to z2 because the pipe is horizontal. So what does the equation happens? The equation is what? P1 by rho g plus V1 square by 2g. This both z get cancelled because they are equal, no? So P1 by rho g plus V1 square by 2g is equal to P2 by rho g plus V2 square by 2g. So what I have done, I just took the Bernoulli's equation and I applied on the Venturimeter. So at section 1 and section 2, so as it is horizontal, Z1 and Z2 are equal. So Z1 get cancels. So P1 by rho g plus V1 square by 2g is equal to P2 by rho g plus V2 square by 2g. Now I'll rearrange them. Okay. So I'll take all the p terms and v terms separately. So what it happens? So p1 minus p2. So this will go this side. So p1 minus p2 divided by rho g. So common. Okay. This this will go this side. That is v2 square by 2g minus this v1 square by 2g. So we will get this equation, that is p1 by p2 by rho g is equal to v2 square by 2g minus v1 square by 2g. Okay. So but this is what? Difference in pressure heads. Okay. P1 by P2 divided by rho g. What is this? Actually, this is what? Difference of pressure head at section 1 and 2. So this we can call it as what? Difference in pressure head means it is indicating what? H, right? Okay. So this is equal to what? H. So but P1 minus P2 by rho g is the difference of pressure heads at section 1 and 2. So it is equal to what? H, or P1 minus P2 by rho g is equal to what? H. Now in the place of P1 minus P2 divided by rho g, we can put it as H. So what it happens? H is equal to V2 square by 2g minus V1 square by 2g. Okay. The pressure head, that is P1 minus P2 by rho g is equal to V2 square by 2g minus V1 square by 2g. Here we will take P1 minus P2 by rho g as what? H, because it is the pressure head or difference of pressure head at section 1 and 2. So now we will apply what? The continuity equation. So what is the continuity equation? A1 V1 is equal to A2 V2. Okay. So now we apply the continuity equation at section 1 and 2, that is a1 v1 is equal to a2 v2. So from this equation what we can find, that v1 is equal to what, a2 v2 divided by a1. Okay, so v1 is equal to a2 v2 by a1. Now what we have to do, we have to substitute back this v1 here. Okay, from this continuity equation we will take a term for v1. So now this v1 we will substitute where, here, where in the h is equal to v2 square by 2g minus v1 square by 2g. In the place of v1 we will write this a2 by a2 v2 by a1. Okay, so now we will see. So substituting the value of v1 in equation, above equation, so what we are getting, so h is equal to v2 square by 2g minus, this is what term, v1 square, this is nothing but your v1 square, v1 ಇದು ಜಾಗದಲ್ಲಿ ಏನು ಹಾಕಿವಿ ನಾವು a2 v2 divided by a1. okay, square alva, so whole square divided by 2g. So once we substitute, what it happens, v2 square by 2g. okay, so substitute it, you will get this equation because it will be multiplied. So after simplification what it happens, v2 square by 2g into 1 minus a2 square divided by a1 square. So again simplifying, what we will get, v2 square by 2g a1 square minus a2 square divided by a1 square. So from h, what was that, v2 square by 2g minus v1 square by 2g to alinda ellige bundi now, this h is equal to what, v2 square by 2g divided by a1 square minus a2 square divided by a1 square. Correct? So now what I'll do, so I'll take this term, this h is equal to, I'll take and I'll transfer all this to this side and I'll find the term, what is that, v2. okay, so v2 square is equal to, what I'll do, I'll send all this to that side, that is 2gh. okay, what happens here, 2gh into, this will be reciprocal, right? So a1 square, just mathematics is the substitution, that's it. a1 square minus a2 square is equal to what, they were, is equal to your v2 square. Now we'll get a term for v2, that is v2 square is equal to 2gh a1 square divided by a1 square minus a2 square. okay, so I'll transfer the square root to here, that is, that will become what, square root. So v2 is equal to root 2gh a1 square divided by a1 square minus a2 square. okay, so I'll take the common terms, that is I'll take the square terms outside, that is a1 square is the square root alladre enagutte, a1 agutte. So a1 minus a2, that will be in the square root only. So a1 square minus a2 square into root 2gh. okay, so I got the value of what, v2. okay, I know also the value of what, a2. So what we need, I need what, discharge. So what is q, q is equal to a2 into v2 is the discharge. okay, q is equal to a2 into v2. So a2 I know by, what is that, pi by 4 into d2 square ಮಾಡಿದ್ರೆ ನನಗೆ a2 ಸಿಗುತ್ತೆ. So v2 value is this a1 by root a1 square minus a2 square into root 2gh. So discharge is equal to what, q is equal to a2 v2, that is equal to a2 is into a1 divided by root of a1 square minus a2 square into root 2gh is equal to a1 into a2 divided by this one into 2gh. So we are getting the formula for what, q. So what is the necessity of this Venturimeter? So it's a device used for measuring the rate of flow. What is this rate of flow? It is nothing but discharge, q. So rate of flow of fluid flowing through a point. So what is the formula? So this equation gives the discharge under ideal condition. okay, and is called as theoretical discharge. This discharge which we will find, no, so this is what the theoretical discharge. So actual discharge ಏನಾಗುತ್ತಲ್ಲ ಅದೇನಾಗಿರುತ್ತೆ, actually less ಇರುತ್ತೆ. So the actual discharge will be less than the theoretical discharge. So ಅದಕ್ಕೆ ಇನ್ನೊಂದು ಏನಿದೆ formula ಇದೆ, we will substitute, we will take one of the coefficient, that is q actual. So I have, so So Q actual is equal to what? Q actual is equal to, just we will multiply with CD, where CD is what? The coefficient of Venturimeter, and it is less than 1. Okay. So Q actual is equal to what? CD into same A1 into A2 divided by root of A1 square minus A2 square into root 2GH. Okay. So whenever we use the formula, we will use this formula for the question based on the Venturimeter, that is Q actual is equal to CD into A1 into A2 divided by root of A1 square minus A2 square into 2GH. Okay. So this was the formula when we use for the problem based on the Venturimeter. Okay. Here we will have a question arising that value of H. Okay. The value of H is given by the differential YouTube manometer, and whenever we will take the YouTube manometer, we have different cases, right? We have already seen in our first unit. So we will discuss about the cases. Okay. So the value of H given by the differential YouTube manometer. Okay. So case 1. So let the differential manometer contains a liquid which is heavier than the liquid flowing through a pipe. So whenever the manometer is contains a liquid which is heavier than the liquid flowing through pipe, ಅವಾಗ ಏನಾಗುತ್ತೆ? Okay. So let SH be the specific gravity of heavier liquid, S0 is the specific gravity of liquid flowing through the pipe, and X is the difference of heavier liquid column in U2. Okay, in U2 manometer. So I just defined it. Okay, nothing I did. I did what? Specific gravity of heavier liquid, specific gravity of liquid flowing through pipe. X is the difference of heavier liquid column in the difference of heavier liquid column in U2 manometer. So the value of H will be, remember this. So H is equal to X into SH divided by S0 minus 1. So H is equal to what? The value of H, how we will find? With this formula, H is equal to X into SH by S0 minus 1. So when we solve 2 to 3 problems now, it will be, we will become comfortable with that, and it will go to our mind easily. Okay, just we have to recollect it. So H is equal to what? Whenever the liquid containing in the differential manometer is heavier than the liquid through the pipe, then we have to use the formula H is equal to X SH divided by S0 minus 1. So once we find H value, we can go to the values. This Q actually is equal to CD into A1 into A2 divided by A1 square minus A2 square into 2GH. Okay, then we have to find the discharge. So this was the case 1. We will see another case, that is case 2. So here, if the differential manometer contains a liquid which is lighter, earlier it was heavier, here it is lighter than the liquid flowing through the pipe, the value of H is given by. So when the liquid is lighter, okay, then what is the formula? That is H is equal to X into 1 minus SL. So SL is what? Specific gravity of the lighter liquid in U2 manometer. Okay. S0 is what? Specific gravity of flowing fluid through pipe. Same. X is the difference of lighter liquid columns in U2. Okay. So H is equal to what? X into 1 minus SL divided by S0. When it was heavier, H is equal to X into heavier, no? So SH minus SS divided by S0 minus 1. So when it is lighter, X is equal to 1 minus S1 divided by S0. So when it is lighter, it is less than 1. Okay, S0 is common, the denominator. So remembering tricks I am telling you. When it is heavier, we have to divide and subtract. When it is lower, means lighter, we have to divide, then we have to subtract in 1. Okay, so S0 is common here. So heavier minus 1, here 1 minus lighter, like this. Okay, these are two cases. Then again, when the Venturimeter is inclined, now what we have to do? This is the case 3. Okay, so inclined Venturimeter with differential U2 manometer. So about two cases for a cases are given for a horizontal Venturimeter, which I shown you earlier the picture. So this case is related to the inclined Venturimeter having different U2 manometer. So let the differential manometer contain heavier liquid than H is given by. So the differential manometer contains a liquid, heavier liquid. Okay, first case one. But here the venturimeter is inclined. Okay, the venturimeter is inclined like this. Okay, the venturimeter is only inclined, and the what is that heavy liquid contained, which differential manometer contains, is heavier. In that case, what is the formula? That is H is equal to P1 by rho g plus Z1 minus section 1. Okay, 1 means at section 1 minus P2 by rho g plus Z2 at section 2. Okay, is equal to what? X is equal to SH by S0 minus 1. So we have to use this formula. Okay, this is the case 1 formula only. Just we have to equate this with P1 by rho g plus Z1 minus P2 by rho g plus Z2. Okay, whenever the venturimeter is what? Inclined. So case 4. So similarly, for inclined venturimeter, in which differential manometers contains a liquid which is lighter than the liquid flowing through the pipe, the value of H is given by, so same, P1 by rho g plus Z1 minus P2 by rho g plus Z2 is equal to what? X is equal to 1 minus SL by S0. Okay. So what case 1 and case 2? This is the case 2, right? Just we have to equate with P1 by rho g plus Z1 minus P2 by rho g plus Z2. Okay, so this is the derivation, and with that derivation we saw some of the cases regarding the value of difference of heads in section 1 and section 2. Now we will see the types of venturimeter. Okay, so this is the horizontal venturimeter. See here. Okay, this is the horizontal venturimeter section 1 and section 2. Here kinetic energy, the flowing fluid is maximum. Okay, the potential energy is negligible, minimum. Okay, because it is horizontal, no potential energy, what it wants, what it should be, it wants the head. Okay, head idre matra potential energy irutte, ade idu inclined idre potential energy will be maximum, kinetic energy will be minimum. But here in the horizontal venturimeter, kinetic energy is maximum, potential energy is minimum or negligible, we can say. So next is inclined venturimeter. So see here, inclined venturimeter, the U2 manometer. Okay, so section 1 and section 2, like this it will be there. Okay, just I am showing the picture to you which we saw in the cases, right? So next, vertical venturimeter. So in this case, what happens? The potential energy is maximum. Okay, and kinetic energy is minimum, because the venturimeter is vertical, right? Whereas the formula for Q and all remains the same. Okay, we have to change some of the terms with respect to the condition of the problem. So here I conclude my lecture on this venturimeter, and we'll see the problems in our next class. So thank you, have a good day ahead.